This video is about something called scientific notation. I actually lied in my last video, 1.6, which was on measurement, because I thought that would be the last of the kind of first group, the first chapter, as it were, of videos. I ended that last video with just a very quick mention of scientific notation, and after I did it, I felt guilty. I thought, man, that was quick, that was so brief. How could anybody get an idea of what scientific notation was from just that quick mention at the end? So I decided to do a whole video on scientific notation. What is scientific notation? Well, it has to do with when we have really, really big numbers or really, really small numbers. So a really, really big number might be, a 1 with a whole mess of zeros after it. Or a small number might be a decimal with a whole bunch of zeros before you actually get to your number. How are we going to do that? We're going to write it out all the time. Man, that's going to be horrible. For example, just as an example, atoms and particles are so small that any usable amount of them will involve lots and lots of them. Now, we haven't really gotten into atoms yet, but we will later in the second chapter, as it were, second group of videos. Atoms are basically what everything is made up of. If you boil everything down to its basic components, everything is made up of atoms. I think I mentioned that in a previous video. Particles are things inside those atoms, so they're even smaller than atoms. We can't comprehend how small atoms are. I mean, you could shrink and shrink and shrink and shrink and shrink. You can't imagine how small an atom is, or a particle in an atom. And so when we begin to talk about any usable amount of atoms or any usable amount of, say, electrons are little negatively charged particles inside the atom that make up electricity. When we begin to talk about electrons, we're talking about something smaller than we can really understand or comprehend. And so, for example, if any of you want to be an electrician or work with electricity, there's something called an amp. My house here can handle a capacity of 200 amps at any one time. If you put on more things in this house, more than 200 amps of electricity in this house, that thing will break off, a circuit breaker will go, all the lights will go off. And so an amp is a measurement of how many electrons, as it were, are flowing through the house at any one time. When I turn this light on, I send a bunch of electrons to that lamp. An amp is basically 6, let me see if I have this right, 6, is it sextillion? Let's see, thousand, million, billion, trillion, quadrillion, quintillion, sextillion. Yeah, 6 sextillion, 250 quadrillion electrons passing at any point in the circuit at any second. That's a whole lot of electrons. That's a large, large number. Again, you don't need to know about amps. That's probably more of a physics course kind of thing. I just wanted to get a really big number in front of you. That's a really big number. Now we will, in the second group of videos, chapter 2 as it were, talk about a mole of atoms. And I don't know why they call it a mole, but a mole of atoms is like 600, I think that's also sextillion. Let's see, thousand, million, billion, trillion, quadrillion, quintillion, sextillion, septillion. 600 septillion atoms is called a mole of atoms, and we'll talk about that in a later video. That's a whole lot of atoms. You don't want to write that out every time you use it. And of course you can go really small too. So the charge on an electron is negative. I'm not going to even guess what that is. I could do it, if I were to, write it out. Or go one by one, but basically that's a very, very 0.0000000. That's a whole lot of decimal zeros before you get to a meaningful number. Coulombs, again, that's physics. You don't need to know what a coulomb is. But basically, these are such humongously big or small numbers that it's not going to do to just write them out every time. And so it was an ancient Greek, actually, that came up with scientific notation, Archimedes. And then it was a French guy named Descartes in the 1500s who helped bring it into the form that we now use in science and math. So think of large numbers or small numbers in this way. So 60 is 6 times 10, right? That's fairly easy math. Now, remember, I hope if you're in a chemistry class that you've already had exponents. So 10, another way to write 10 is 10 to the first power. 10 to the 0th power is just 1. 10 to the first power is 10. 10 to the second power is 100. 10 to the second power means 10 times 10, and that's 100. It has 2 zeros, right? You can see that each power of 10 has 1 zero. So 10 to the first power has 1 zero. 10 to the 0th power has no zeros, it's just 1. 10 to the second power has 2 zeros, it's 100. So again, hopefully this is familiar, or at least was at one point when you had algebra. So 600 then is 6 times 100. And 100, as I just said, is 10 to the second power. Can you see a pattern developing here? So this 600 septillion, if I counted it right, is 6 times 10 to the 23rd power. Why? Because there's 23 zeros. If you count all those zeros, there are 23 zeros. So you can see how it's a lot easier to write 6 times 10 to the 23rd power than it is to write 600000000, and so on. And so this is scientific notation. It is a simplified way of writing really, really big or really, really small numbers. That's how scientific notation works. Well, let's look at it for really small numbers. So we mentioned this very small number of coulombs. By the way, since electrons have a negative charge, there's a negative in front of this. So what is this? This is going to be 1.6 times 10 to the negative 19th power. So when you have a negative power, that means it's going smaller. So you have a decimal point and 19 spaces before you get to where the decimal is by the 1. If you count spaces over till we get to right after the 1, you would find that there are 19 spaces. So 1.6 times 10 to the negative 19th power is a way of writing this very small number. I should have put a negative in front of it. Sorry. Okay, so there are some prefixes that I'll end this video with. So 10 to the third power is kilo. That's 1,000 times something. So a kilometer, a kilometer, a kilometer is 1,000 meters. Or a kilogram is 1,000 grams. Or a kilowatt is 1,000 watts. And so forth. A kilovolt in electricity is 1,000 volts, and so forth. 10 to the sixth is mega. So that's a 1 with that's a million times whatever. So a megawatt is a measure of power in having to do with electricity often. So that's a million watts. So mega. 10 to the minus third is milli. So a millimeter is 1/100th of a meter, and a micrometer would be what did I say? 10 to the negative third is 1,000th of a meter. I don't know what I said. 10 to the negative 6 is 1/1,000,000th of a meter. Okay? So these are some helpful prefixes. Scientific notation really isn't that hard. Don't let it get to you. It's just get the paper bag, brown paper bag, breathe into it several times, watch this video again, and you'll be just fine.